Good day! Welcome in today's episode of DepEd TV. I am Sir Jason Flores Oso, your math buddy, and I will be here to help you in developing your logical reasoning and critical thinking skills. Is your self-learning module ready? What about your pen and paper? Great! Let's begin a fun and exciting lesson. For this lesson, you are expected to, first, find the sum of the first n terms of an arithmetic sequence, and second, solve word problems involving arithmetic series. In the previous episode, it was discussed that to find the nth term of an arithmetic sequence, the formula a sub n is equal to a sub 1 plus d times n minus 1 can be used. In this episode, we will discuss how to find the sum of the first n terms of a given arithmetic sequence. For example, how do we compute the sum of all the terms of each of the following sequences? Letter A, 1, 2, 3, up to 100. And letter B, 5, 10, 15, 20, up to 50. Adding manually the terms of a sequence is manageable when there are only few terms in the sequence. However, if the sequence involves numerous terms, then it is no longer practical to be adding the terms manually. It is a tedious work to do. Thus, this episode will present to you a formula that will make the computation faster and easier. To let you experience getting the sum of the terms in a sequence manually, let's do the following. Number 1. Find the sum of the first 20 natural numbers. By listing all the natural numbers from 1 to 20 and adding them, we have 1 plus 2 plus 3 plus 4 up to 20, that is equal to 210. Thus, the sum of the first 20 natural numbers is 210. Number 2. Find the sum of all the terms of the sequence 5, 10, 15, 20, up to 50. By listing all the terms of the sequence and adding them, we have 5 plus 10 plus 15 plus 20 up to 50, you will get 275. Thus, the sum of the terms of the sequence is 275. What if you're asked to find the sum of the terms of the sequence 1, 2, 3, up to 10,000? There are 10,000 terms to be added one by one to get their sum, right? In doing this kind of solution, it is very challenging, especially if you're dealing with a sequence that has many terms. In getting the sum of the terms of an arithmetic sequence, we will be using any of the following formula. S sub n is equal to n divided by 2 times a sub 1 plus a sub n if the first and last term are given. Again, if the first and last term are given, we will use the formula S sub n is equal to n divided by 2 times a sub 1 plus a sub n, where S sub n is the sum of the first n terms. N corresponds to the nth position. A sub 1 is the first term of the sequence, and a sub n is the last term. On the other hand, if the last term is not given, we will use the formula S sub n is equal to n divided by 2 times the quantity 2 times a sub 1 plus n minus 1 times d. Again, if the last term is not given, we will use the formula s sub n is equal to n divided by 2 times the quantity 2 times a sub 1 plus n minus 1 times d, where s sub n is the sum of the first n terms, a sub 1 is the first term of the sequence, and d is the common difference. Let's take a look at these examples. Find the sum of the first 20 natural numbers. From this sequence, we can see that our a sub 1 is equal to 1, our a sub n is equal to 20, our n is equal to 20, and we are looking for s sub n. Since the first and last terms are given, we will use the formula s sub n is equal to n divided by 2 times a sub 1 plus a sub n. Substituting the given values in the formula, we will have s sub 20 is equal to, our n is 20 divided by 2 times our a sub 1 is 1 plus our a sub n is equal to 20. Next, we will have s sub 20 is equal to 20 divided by 2 will give us 10, and 1 plus 20 will give us 21. Our s sub 20 will be the product of 10 and 21. We will get 210. Therefore, the sum of the first 20 natural numbers is 210. Now, let's go to the next example. Find the sum of the first 16 terms of the arithmetic sequence 8, 11, 14, 17, 20, and so on. Notice that in this sequence, the given are a sub 1, which is equal to 8. Our n is equal to 16. The difference is 3, and we are looking for the sum of the first 16 terms. Notice that the last term is not given, so we will use the formula s sub n is equal to n divided by 2 times the quantity 2 times a sub 1 plus n minus 1 times d. By substituting the given values in the formula, we will have s sub 16 is equal to, our n is 16 divided by 2 times the quantity 2, our a sub 1 is 8 plus our n is 16 minus 1 times the difference, which is 3. Next, we will have s sub 16 is equal to 16 divided by 2 is 8 times the quantity 2 times 8 will give us 16 plus 16 minus 1 is 15, and the difference of 3. Next, we will have s sub 16 is equal to 8 times the quantity 16 plus 15 times 3 will give us 45. Next, we'll have s sub 16 is equal to 8 times the quantity of 16 plus 45 will give us 61. Our S sub 16 is equal to the product of 8 and 61, that is equal to 488. Thus, the sum of the first 16 terms of the series is 488. Great! Now, let's move forward to the next example. After knowing all the needed concepts in finding the sum of an arithmetic sequence, let's try to answer the following exercises. Find the sum of each arithmetic series. The first one, find the sum of the first 30 terms of the arithmetic sequence 1 plus 3 plus 5 and so on. Notice that in this problem, our given a sub 1 is equal to 1, our n is 30, our difference is 2, as you can see, by adding the difference to the preceding term to get the next term. And we are looking for S sub 30. With this problem, the last term is not given, so we will use the formula S sub n is equal to n divided by 2 times the quantity 2 times a sub 1 plus n minus 1 times d. Substituting the values in the formula, we will get S sub 30 is equal to, our n again is 30 divided by 2 times the quantity 2 times a sub 1, which is 1, plus our n again is 30 minus 1 times the difference 2. Next, we have S sub 30 is equal to 30 divided by 2 will give us 15 times the quantity 2 times 1 is 2 plus 30 minus 1 will give us 29 times the difference 2. Moving forward, we will have S sub 30 is equal to 15 plus, or the quantity 2 plus 29 times 2 is equal to 58. S sub 30 is equal to 15 times the quantity of 2 plus 58, that's 60. Our S sub 30, therefore, is the product of 60 and 15. We will get 900. Thus, the sum of the first 30 terms of the sequence is equal to 900. Excellent! Let's boost up your learning with another example. Find the sum of the sequence 1, 2, 3, 4, up to 10,000. From the sequence, we can notice that the given a sub 1 or first term is equal to 1. Our n is equal to 10,000. Our a sub n is equal to 10,000, and we are looking for S sub n. Also, notice that the first and the last term are given, so we will use the formula S sub n is equal to n divided by 2 times a sub 1 plus a sub n. Substitute the values in the given formula. We will have S sub 10,000 is equal to, our n again is 10,000 divided by 2 times the first term, which is 1, plus our a sub n, which is 10,000. Next, we have S sub 10,000 is equal to 10,000 divided by 2 will give us 5,000 times the sum of 1 and 10,000, you will have 10,001. Our S sub 10,000 now is the product of 5,000 and 10,001. It will give us this term. Therefore, the S sub 10,000 of the sequence is 50,005,000. Oh, so awesome! Fasten your seatbelts as we proceed to the next exercise. Find the sum of the first 13 terms of the sequence -3, -1, 1, 3, and so on. Notice that from the sequence our given, a sub 1 or the first term is -3. Our n is 13. The difference is 2, that is by adding the common difference to the preceding term to get the next term. And we are looking for S sub 13. Since the last term is not given, we will use the formula S sub n is equal to n divided by 2 times the quantity 2 times a sub 1 plus n minus 1 times the difference. Again, substitute the values in the formula. We will have S sub 13 is equal to n, which is 13, divided by 2 times the quantity 2 times a sub 1, that is -3, plus our n, which is 13, minus 1 times the difference, which is 2. Next, we have S sub 13 is equal to 13 divided by 2 will give us, correct, 6.5 times the quantity 2 times -3. This will be equal to -6 plus 13 minus 1 will give us 12 and times the difference, which is 2. Moving on, we have S sub 13 is equal to 6.5 times the quantity -6 plus the product of 12 and 2 will give us 24. Next, we have S sub 13 is equal to 6.5 times, get the sum of -6 and 24 will give us +18. That's correct. Then our S sub 13 now will be equal to the product of 6.5 and 18. We will have 117. So the sum of the 13 terms of this sequence is equal to 117. How's that? Oh, so amazing! Well done! Congratulations, dear students! On this part, let us see what you have learned from today's episode by answering the following questions. To find the sum of the terms of an arithmetic sequence, what formula can we use if the first term and last term are given? If the first term and last term are given, we use the formula S sub n is equal to n divided by 2 times a sub 1 plus a sub n. What about if the last term is not given? What formula can we use? If the last term is not given, we use the formula S sub n is equal to n divided by 2 times the quantity 2 times a sub 1 plus n minus 1 times d. Now, let's apply what you have learned by solving the given word problem. Jane was saving for a pair of shoes. From her weekly allowance, she was able to save 5 pesos on the first week, 9 pesos on the second, 13 pesos on the third week, and so on. If she continued saving in this pattern and made 43 deposits, how much did Jane save? Let's analyze and solve the problem together. From the given problem, we can see that our first term, or a sub 1, is equal to 5 pesos. Our n is equal to 43. The difference is equal to 4. And we're looking for s sub n. Since the last term is not given, we will use the formula s sub n is equal to n divided by 2 times the quantity 2 times a sub 1 plus n minus 1 times d. Substituting the values in the formula, we will have s sub 43 is equal to 43 divided by 2 times the quantity 2 times 5 plus 43 minus 1 times 4. S sub 43 is equal to 43 divided by 2 is equal to 21.5 times the quantity 2 times 5 is 10 plus 43 minus 1 is 42 times 4. S sub 43 is equal to 21.5 times the quantity 10 plus the product of 42 and 4, that is 168. S sub 43 is equal to 21.5 times the sum of 10 and 168, that's 178. S sub 43 is the product of 21.5 and 178, that is equal to 3,827. Thus, after 43 deposits, Jane can save 3,827 pesos. Like Jane, you too can save. Start now. Your 5 pesos can make a difference. Oh, so awesome, right? I hope you learned a lot. Keep practicing because math is always part of our daily lives. And that concludes our lesson for today. See you again on the next episode. And this has been Sir Jason Flores also. Bear in mind that learning math will always be fun and easy. Be also, be awesome. Only here on DepEd TV.